Have you ever wondered if the world behind you disappears the moment you stop looking at it? It sounds like a question a child might ask before drifting off to sleep, a fleeting thought born in the quiet moments of the night. You close your eyes, and the room fades away. You open them, and everything is exactly as you left it. We move through our lives with a deep, unspoken trust that reality is solid, that the universe exists independently of our gaze. We believe that the ancient mountains, the vast oceans, and the silent stars are there, waiting in the darkness, whether we cast our eyes upon them or not. But what if this comforting certainty is nothing more than a beautiful illusion? What if the very fabric of the cosmos requires a witness to weave itself into existence? This is not the premise of a science fiction story. It is the haunting implication of one of the most rigorously tested scientific frameworks in human history: quantum mechanics. It is a mystery that has kept some of the most brilliant minds awake at night, staring into the infinite dark, wondering about the fundamental nature of what is real. Before we dive deeper into this gentle journey through the quantum realm, I want to take a brief moment to welcome you. I am Theodore, the researcher, and it is a privilege to share these cosmic explorations with you. I noticed recently that 71% of the wonderful people who watch these videos have not yet subscribed to the channel. If you find peace and wonder in these explorations of the universe, please consider subscribing. It helps immensely and ensures we can continue to wander through these quiet mysteries together. Now, let us return to the strange and beautiful world of the very small. To understand the profound paradox that terrified the founding figures of modern physics, we must travel back in time to the year 1801. A brilliant English polymath named Thomas Young devised an experiment that was elegantly simple, yet its echoes would eventually shatter our understanding of reality. Young wanted to know if light was made of tiny, solid particles, or if it traveled in continuous, sweeping waves. He set up a light source and aimed it at a solid barrier pierced by two narrow, parallel slits. Behind this barrier, he placed a screen to capture the light that passed through. If light were made of little particles like tiny grains of cosmic sand, they would pass through the two slits and form two distinct, bright lines on the screen. But that is not what Young saw. Instead, he observed a beautiful, alternating pattern of light and dark bands spreading across the screen. This is a classic interference pattern, the unmistakable signature of waves. Imagine dropping two pebbles into a quiet, still pond. The ripples spread outward, gently intersecting. Where the crests of two waves meet, they amplify each other, creating a higher peak. Where a crest meets a trough, they cancel each other out, leaving a calm surface. This was exactly what the light was doing. Young's experiment seemed to settle the debate. Light was a wave, but the universe, in its infinite majesty, is rarely simple. Fast forward a little over 100 years to the early 20th century. A new generation of physicists, armed with more precise instruments and a growing sense of wonder, began to probe the boundaries of the atomic world. They discovered that light was not just a continuous wave. It was quantized into discrete, indivisible packets of energy called photons. The scientific community decided to recreate Thomas Young's famous double-slit experiment, but with a profound twist. They developed technology capable of firing single, solitary photons at the barrier, one at a time. It was a slow, solitary journey for each photon, traveling through the dark vacuum to meet its destiny on the screen. Since they were firing solid particles of light one by one, Logic dictated that each photon would pass through one slit or the other, building up those two distinct lines. The physicists waited in the silence of their laboratories, watching the pattern slowly emerge, dot by dot. But as the thousands of tiny flashes accumulated on the screen, a ghost appeared. The photons, fired one by one, with no other particles to interact with, were not forming two lines. They were building the exact same alternating pattern of light and dark bands, an interference pattern. This result was entirely counterintuitive. It defied everything we thought we knew about the physical world. For a single particle to create an interference pattern, it would have to travel as a wave of possibilities, pass through both slits simultaneously, interfere with its own self, and then suddenly collapse back into a solid, defined particle the moment it struck the screen. The brilliant physicist Richard Feynman once said that this phenomenon contains the only true mystery of quantum mechanics. It is a mystery that forces us to question the very nature of existence. But the mystery deepens, growing even more profound and unsettling. The physicists, driven by a natural human curiosity, wanted to know exactly which slit the individual photon was passing through. So, they placed highly sensitive measuring devices, tiny artificial eyes, right next to the slits to watch the particles as they passed. They fired the photons again, one by one. The detectors did their job perfectly, registering a small click each time a photon went through the left slit or the right slit. The researchers had caught the particles in the act, but when they looked at the final screen, the universe had played a breathtaking trick on them. The beautiful, sweeping interference pattern had vanished. In its place were just two distinct, bright lines. The mere act of observation, the simple presence of a witness, had fundamentally altered the behavior of the universe. When no one was looking, the light acted like a wave of endless potential, existing in a state of superposition, occupying many places at once. But the moment it was observed, the moment an inquiry was made, the wave function collapsed. The endless possibilities crystallized into a single, concrete reality. The photon behaved like a solid particle, choosing a definitive path. It was as if the universe knew it was being watched, and immediately disguised its true, shimmering nature. This is the famous observer effect, a cornerstone of quantum mechanics that has survived nearly 100 years of the most rigorous testing human beings can devise. It is a concept that terrified men like Albert Einstein and Erwin Schrödinger. Einstein, a man who sought elegant, deterministic laws governing the cosmos, could not accept this strange reality. He famously asked his colleagues if they truly believed the moon only existed when they looked at it. It is a profound, almost frightening question, spoken with a gentle irony, but carrying the weight of a fundamental existential crisis. If the foundational building blocks of reality, the photons, the electrons, the atoms that make up our bodies, our planets, and the distant stars, only take on definite properties when they are observed, then what is the universe doing when we are not looking? Is the vast, silent cosmos just a swirling mathematical probability cloud, waiting for a conscious mind to gaze upon it and force it into being? The physicist John Archibald Wheeler, a towering figure in modern science, took this line of thought to its ultimate conclusion. He proposed the participatory anthropic principle. Wheeler suggested that the universe is not a massive, cold machine ticking away independently of us. Instead, he envisioned a participatory universe, a cosmos where the observer is as essential to the creation of reality as the reality is to the observer. He argued that the universe needs a conscious witness to actualize its own existence. Without an observer, there is no reality, only a quiet, ancient potential. Think about the sheer scale of this idea. We look back in time through our powerful telescopes, gazing at ancient galaxies whose light began its journey toward us 13 billion years ago. According to the strictest interpretation of quantum mechanics, that light, traveling for billions of years across the endless void, existed as a wave of probabilities. It was only when that ancient light finally struck the mirror of a telescope and was subsequently observed by a human mind that its state became concrete. This realization brings us to a threshold of understanding where physics begins to blur with philosophy. If the universe requires observation to transition from a hazy cloud of probabilities into the solid reality we experience every day, we are faced with a monumental question. The universe existed for roughly 13,800,000,000 years before the first human eyes opened. For eons, there were no conscious human observers to collapse the wave functions of the primordial stars and the swirling cosmic dust. Who, then, was looking? What kind of cosmic gaze was holding the infinite expanse of the universe in a state of concrete reality before we arrived? We left off with a question that hangs in the quiet spaces between the stars. If the very fabric of reality requires an observer to pull it from a haze of infinite possibilities into a solid, defined state, who was watching the universe before we arrived? Imagine, for a moment, the ancient cosmos, long before the earth cooled, long before the first oceans formed, and long before the first primitive eyes blinked open in the primordial dark. For billions of years, the universe was a magnificent theater with absolutely no audience. According to the strictest interpretations of quantum mechanics, during all those silent eons, the burning stars, the forming galaxies, and the swirling nebulas might not have existed as physical objects in definite, measurable places. Instead, they would have drifted as vast, overlapping waves of pure probability, a silent, ghostly dance of pure mathematics unfolding in the deep dark. But we know with absolute certainty that the universe evolved. We can clearly see its ancient history written in the cosmic microwave background, the faint, fading afterglow of the Big Bang itself. We can meticulously measure the age of ancient stars and trace the slow, majestic formation of massive galactic clusters across the void. The universe was clearly doing something, building something, and moving forward through the river of time. So, how did the wave function of the entire cosmos collapse into the breathtaking reality we inhabit today, without a conscious mind to look at it? To answer this profound mystery, we must wade into intellectual waters that terrified even the most brilliant physicists of the 20th century. We must look closely at the groundbreaking work of mathematical giants like John von Neumann and the Nobel laureate Eugene Wigner. They took the rigorous mathematics of quantum mechanics to its absolute, logical, and perhaps deeply terrifying conclusion. John von Neumann laid the incredibly rigorous mathematical foundations of quantum theory, and as he worked through the equations, he realized there was a profound problem, a glaring gap in the numbers. The beautiful mathematics perfectly described the continuous, flowing evolution of the probability wave, but they could not mathematically explain the collapse itself. There was absolutely nothing in the physics, no mechanical trigger, no physical force, and no hidden mechanism that dictated when or why a particle should suddenly abandon its infinite possibilities and choose a single, definite state. The only thing that consistently caused the collapse in their meticulous laboratory experiments was the introduction of a measuring device, and ultimately the conscious mind reading the results of that device. Eugene Wigner took this mathematical truth and proposed something deeply radical and philosophically earth-shattering. He argued that it is not the physical measuring device that collapses the wave function. After all, a camera, a highly sensitive sensor, or a powerful computer is just made of more atoms, more quantum particles, which should theoretically also exist in a state of superposition until they are observed by something else. Wigner reasoned that an unbroken chain of quantum superpositions would extend infinitely outward, layering upon itself forever, unless something fundamentally different from physical matter intervened to break the endless chain. That elusive something, he concluded with a heavy heart, had to be human consciousness. It was a staggering proposition. Wigner suggested that the consciousness of the observer is the ultimate, necessary ingredient for reality to physically manifest. To illustrate this, he proposed a thought experiment that became famous as Wigner's friend. Imagine you place a trusted friend inside a perfectly isolated laboratory to perform the famous double-slit experiment. Your friend fires the solitary photon, measures which slit it goes through, and carefully records the definitive result. Inside that isolated, quiet room, your friend's consciousness has collapsed the wave function. The photon has a definite reality for them, but you are standing outside the laboratory, in the hallway completely cut off from the information inside. For you, according to the strict, unforgiving rules of quantum mechanics, your friend, the measuring device, and the tiny photon are all still entangled in a massive, complex state of superposition. For you, standing in the silence, the event has not yet happened in a definite way. It is only when you finally open the heavy door, step into the quiet laboratory, and gently ask your friend for the result, that your own consciousness collapses the wave function of the entire room, forcing it into a single, shared reality. This elegant thought experiment implies a universe where reality is inherently subjective, where the cosmos is a layered onion of observations, each individual consciousness forcing the universe to commit to a physical state. But this leads us directly back to the terrifying void of the early universe. If human consciousness is the required trigger, the fundamental key that unlocks reality from the shadowy realm of probability, we are trapped in a profound, inescapable paradox. Human beings have only existed for a microscopic fraction of a cosmic second. How could our relatively recent arrival collapse the wave function of a universe that is 13,800,000,000 years old? This is the exact paradox that led some of the greatest scientific minds in human history to whisper a word, usually reserved for theologians and philosophers. They began to wonder, in the late hours of the night, if the cold mathematics of quantum mechanics were actually pointing toward the existence of a universal observer. If a conscious gaze is the fundamental requirement for reality, and the universe has clearly been real for billions of years before biological life ever evolved on our small rocky planet, then basic logic demands a consciousness that is as ancient and vast as the cosmos itself, an ever-present witness to the unfolding of space-time. This is the theory that terrifies physicists, not because it invokes traditional religion, but because the cold, hard mathematics of their own rigorous discipline seem to leave a profound, unexplainable void that only an omnipresent observer can fill. It is a concept that some daring thinkers have called the quantum God. But we must be very careful here, taking gentle, deliberate steps as we navigate the fragile boundary between hard science and boundless wonder. This universal observer is not necessarily a deity in the traditional human sense. It is not a figure sitting in the clouds, judging human actions or listening to our quiet prayers in the dark. Instead, It is a foundational awareness, a fundamental, inherent property of the universe, woven into the very fabric of reality, just as gravity or electromagnetism is woven into the cosmos. Imagine this universal consciousness as a quiet, infinite presence, a silent, unbroken witness that permeates every single cubic inch of the vast cosmos. It is the steady gaze that held the early stars in place, the ancient awareness that watched the slow, majestic collision of primordial galaxies, forcing their majestic probability waves to crystallize into the glowing dust and burning gas we see today through our most powerful telescopes. The brilliant theoretical physicist John Archibald Wheeler, a man who dared to stare deeply into the abyss of quantum strangeness and who gave us the term black hole, spent his later years deeply troubled and fascinated by this very concept. He drew a famous diagram, an elegant, simple illustration of a giant letter U representing the entirety of the universe. One side of the U is the ancient past, the fiery Big Bang, the explosive birth of absolutely everything. The other side of the U slowly grows an eye, looking back across the gulf of time at its own violent origin. Wheeler called this the participatory universe. He proposed a breathtaking idea that the universe gave rise to conscious beings, specifically so that those beings could look back in time through telescopes and mathematics, and by the very act of observing the ancient past, bring that past into concrete reality. It is a closed loop of existence, a cosmic Ouroboros, where the observer and the observed create each other in an infinite, timeless dance. We are not just biological accidents, drifting on a tiny rock through a cold, indifferent, endless void. In this beautiful view, we are the universe waking up, opening its eyes, and looking at itself for the first time. We are the mechanism by which the cosmos makes itself real. Every time you step outside and look up at the night sky, every time you let your eyes wander gently across the faint, ancient light of the Milky Way, you are not just a passive spectator enjoying the view. You are actively participating in the ongoing creation of the universe. Your quiet, contemplative gaze is collapsing wave functions that have been traveling through the deep, frozen silence of space for millions of years just to reach your eyes. This beautiful idea fundamentally shifts our entire relationship with the unknown. It transforms the vast, terrifying emptiness of deep space into something intimately, inextricably connected to our own minds. But this profound, almost spiritual connection between the observer and the universe is not limited to the simple act of looking at the distant stars. It is written into the deepest, most baffling mechanics of the fundamental particles themselves. There is another phenomenon in the quantum world, a mystery so deeply unsettling that Albert Einstein famously rejected it to his dying day, calling it spooky action at a distance. It is a phenomenon that definitively proves the universe is not a random collection of isolated, lonely objects drifting in the dark, but a deeply connected, singular entity where distance is merely an illusion created by our limited senses. It is the phenomenon of quantum entanglement. To truly understand the sheer scale of this mystery, you must imagine two tiny particles born together in the furious, crushing heart of a burning star, or created simultaneously in the intense, focused energy of a modern laboratory experiment. Because they share a common, primordial origin, their quantum states become inextricably, permanently linked. They are no longer two separate particles. They are a single, unified system, functioning as one entity, no matter how far apart they travel on their cosmic journey. You could take one of these entangled particles and keep it right here on Earth, safely contained in a quiet, dark laboratory. You could take the other particle and send it on an epic, endless journey across the cosmos, past the edge of our solar system, beyond the gentle glow of the spiral arms of the Milky Way, all the way to the other side of the observable universe, billions of light years away. According to the strict intuitive rules of classical physics, these two particles are completely isolated from one another. Nothing can travel faster than the speed of light, so no signal, no information, and no invisible force could possibly pass between them in an instant. They are entirely alone in the void. But the quantum world does not obey our classical human intuition. If you measure the particle here on Earth, observing it and forcing its delicate wave function to collapse into a definite, solid state, its entangled partner, sitting billions of light years away in the deep cosmic dark, will instantly, in that exact same unmeasurable fraction of a second, collapse into a perfectly corresponding state. The measurement of one immediately and irrevocably determines the reality of the other, bridging an infinite distance in absolute zero time. It is a silent communication that completely ignores the universal speed limit of light, a whisper that crosses the entire universe instantaneously. This completely shatters our fundamental understanding of space and time as concrete, absolute barriers. If two simple particles can be intimately connected across billions of light years, reacting as a single entity without any physical mechanism connecting them, what does this tell us about the fundamental structure of the cosmos? It suggests a universe where absolutely everything is inherently woven together, a quiet, invisible web of relationships where distance means absolutely nothing. It suggests that the illusion of separation is exactly that, an illusion born of our limited human perspective. As we gently explore these deeply counterintuitive truths, we begin to see the outline of a reality that is far more mysterious, far more interconnected, and far more dependent on consciousness than we ever dared to imagine. But if entanglement proves that the universe is a single, undivided whole, and the observer effect proves that reality requires a witness, we are inevitably led to an even deeper, more profound mystery. How does this universal web of entangled particles react when the ultimate observer, whatever that might be, finally casts its gaze upon it? As we stand on the precipice of this profound quantum mystery, breathing in the quiet implications of a deeply interconnected cosmos, let us gently shift our gaze from the microscopic realm of entangled particles to the grandest scale imaginable. Imagine yourself stepping outside on a crisp, clear night, far away from the glowing lights of any human city. You look up, and the sky is a vast ancient tapestry, woven with the pale light of distant, burning suns. In that profound silence, you might feel incredibly small, a fleeting biological spark standing on a fragile rock, adrift in an infinite, dark ocean. But the strange and beautiful truth of our universe is that the unimaginably large and the incomprehensibly small are not separate realms. They are two ends of the exact same continuous journey, intimately bound together by the very quantum rules that terrified Albert Einstein. To understand how the quantum observer might be the architect of the entire universe, we must look at the physical shape of the cosmos itself. We must rewind the clock of eternity, traveling back through 13,800,000,000 years of cosmic history, to a time when the entire universe was smaller than a single grain of sand. It is a journey that requires us to blend the absolute rigor of modern astrophysics with a deep, reverent sense of wonder. In the year 2009, the brilliant scientists and engineers at the European Space Agency launched a magnificent instrument into the cold vacuum of space. They called it the Planck Space Observatory. Its mission was not to look at nearby planets or vibrant spinning galaxies, but to stare deeply into the absolute oldest light in the universe. This ancient light is known as the cosmic microwave background radiation. It is the fading, gentle afterglow of the Big Bang itself, a fossilized whisper from the very dawn of time. When we look at this light, we are looking at the universe exactly as it was 380,000 years after its explosive birth. Before that precise moment, the cosmos was a blinding, impossibly hot fog of chaotic plasma, so dense and energetic that even a single photon of light could not travel more than a microscopic fraction of a millimeter before crashing into an electron. But as the cosmos gently expanded, it also cooled. And at that magical 380,000-year mark, the temperature dropped just enough for the first stable atoms of hydrogen and helium to form. The fog instantly lifted. The universe became transparent, and that primordial light, trapped for eons, was suddenly free to begin its infinite, unbroken journey across the dark expanse of space, eventually falling upon the delicate sensors of our modern satellites. When the scientists at the European Space Agency finally processed the massive amounts of data returned by the Planck Observatory, they did not see a perfectly smooth, uniform glow. Instead, they revealed a stunning, highly detailed map of the infant universe, covered in tiny, incredibly subtle temperature variations. We are talking about differences of mere fractions of a degree, perhaps 100,000th of a degree Celsius, scattered across the entire sky like a gentle, pointillist painting. To the untrained eye, it might look like random static, a meaningless pattern of slightly warmer and slightly cooler spots. But to the trained astrophysicists, this map was the ultimate Rosetta Stone of cosmic history. Those tiny, almost imperceptible temperature fluctuations were the primordial seeds of absolutely everything we see today. The slightly cooler, denser spots possessed just a tiny bit more gravity than the empty space around them. Over billions of years, that gentle, invisible gravitational pull began to drag more and more mysterious dark matter and primordial hydrogen gas together. Those microscopic dense spots slowly grew, gathering mass and momentum, eventually evolving over deep time into the magnificent, swirling galaxies, the vast galaxy clusters, and the sprawling, luminescent cosmic web that gently illuminates our quiet night sky today. But here is where the absolute rigor of science meets the staggering, mind-bending reality of the quantum world. What exactly caused those tiny, primordial temperature differences in the first place? Why wasn't the early universe completely smooth and perfectly uniform? The answer brings us right back to the strange, jittery, probabilistic world of quantum mechanics. In the late 1970s, a theoretical physicist named Alan Guth proposed a concept called cosmic inflation. He realized that in the first unmeasurable fraction of a second after the Big Bang, the universe expanded at a rate that defies all human comprehension, growing from the size of a subatomic particle to the size of a grapefruit in a breathtaking instant, expanding much faster than the speed of light. During that violent, breathtaking expansion, the strange, inherent jitteriness of the quantum world, the tiny, random fluctuations of energy that constantly pop in and out of existence in the empty vacuum, were suddenly caught and stretched across macroscopic distances. The microscopic vibrating waves of quantum probability were instantly frozen and magnified to the scale of the entire cosmos. Think deeply about the profound implication of this scientific truth. When you look through a telescope at a massive galaxy cluster, an impossibly huge structure containing trillions of stars and stretching across millions of light years of empty space, you are not just looking at a random collection of cosmic debris. You are looking at a magnified, fossilized quantum fluctuation. The largest structures in the entire universe are nothing more than the microscopic, uncertain, shifting probabilities of the quantum realm writ large across the canvas of the sky. The macro is the micro. The infinite vastness of the cosmos is intimately, permanently tethered to the bizarre, probabilistic behavior of the subatomic world. And if the entire structural foundation of the universe was born from a quantum state, a state that we know, through rigorous laboratory testing, exists only as a haze of possibilities until it is observed, we are forced to return to that terrifying, beautiful question. Did the ancient, primordial quantum fluctuations require an observer to collapse them into the definite reality that eventually built the stars, the planets, and the very atoms of our bodies? The legendary astronomer Carl Sagan once profoundly stated that we are a way for the cosmos to know itself. He understood with a deep, poetic clarity that we are not separate from the universe. We are not external, biological aliens wandering through a cold, disconnected physical machine. The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, and the carbon in our apple pies were all forged in the collapsing, burning hearts of ancient stars that lived and died billions of years ago. We are literally, physically made of star stuff. When we open our eyes and look out at the deep, ancient mystery of the night sky, we are not just looking at the universe. We are the universe looking at itself. We are the conscious, waking mind of the cosmos, forged over 14 billion years of patient, silent evolution, finally reaching a point of complexity where we can begin to ask profound questions about our own origin. If the universe requires a conscious observer to pull reality from the shifting, uncertain waves of quantum potential, perhaps it spent billions of years blindly building the precise biological machinery needed to finally open an eye and solidify its own majestic existence. This contemplative realization does not offer a simple, definitive resolution. True science rarely does. Instead, it invites us to replace our fear of the unknown with a profound, gentle humility. It asks us to recognize that the limits of our current human knowledge are not a wall to be feared, but a vast, open frontier waiting to be explored. We move through our daily lives, worried about our fleeting, temporary problems, entirely forgetting that we are walking, breathing manifestations of a 14-billion-year-old cosmic quantum paradox. The silence of the universe is not an empty, terrifying void. It is a quiet, patient teacher, slowly revealing its deepest secrets to those who are willing to look up and ask the hard, terrifying questions. As we continue this gentle journey of discovery, moving deeper into the beautiful, confusing heart of modern physics, we must ask what role time itself plays in this cosmic observation. If an observation made today can collapse a wave function that began billions of years ago, does the present moment have the power to literally rewrite the history of the ancient past? Time is perhaps the most intimate and profound mystery we experience. We feel it moving through us, a silent, invisible river that carries us from the fleeting moments of our childhood into the quiet certainty of our present. We watch the seasons change, the green leaves of spring gently turning into the vibrant, burning colors of autumn before falling to the cold, waiting earth. We see the ancient stars slowly tracing their majestic arcs across the night sky, completely bound by the relentless forward march of the cosmic clock. In our everyday human experience, the past is a locked door, a collection of memories and fossilized events that can never be touched, altered, or unmade. The future is an unwritten page waiting to be filled, and the present is the only fragile point of reality where we can actually exist. This intuitive, deep-seated belief in a linear, unyielding timeline is the very foundation of our sanity. But the quantum universe, in its infinite, baffling beauty, does not care about human intuition. It operates on rules so deeply counterintuitive, so profoundly alien to our daily lives, that they force us to question the very nature of cause and effect. What if the silent river of time does not only flow forward? What if the choices we make right now in this exact breathing moment have the terrifying, awe-inspiring power to reach back across billions of years of cosmic history and determine how the ancient past unfolded? Before we step further into this mind-bending river of time, I want to pause for just a moment to gently remind you that you are listening to Theodore, the researcher. We are on a quiet journey together, exploring the most profound mysteries of the cosmos. I have noticed that roughly 71% of the curious minds who watch these videos have not yet subscribed to the channel. If these gentle explorations bring you a sense of peace and a deeper connection to the magnificent universe we share, please consider subscribing. It helps our small community grow immensely and allows us to continue wandering through these beautiful, complex scientific truths together in the dark. Now, let us return to the mystery of time and the quantum particles that seem to ignore its fundamental laws. To understand how the present might physically alter the past, we must return to the brilliant, restless mind of the theoretical physicist John Archibald Wheeler. Wheeler was a man who possessed the rare, beautiful ability to take the cold, rigid mathematics of quantum mechanics and translate them into profound, existential thought experiments that challenged the very limits of human imagination. He was deeply troubled by the observer effect, that undeniable, rigorous laboratory proof that a particle only chooses a definite state when it is measured. He wondered, with a brilliant, audacious curiosity, what would happen if the choice to observe or not observe a particle was delayed until after the particle had already committed to its path. In the late 1970s, Wheeler proposed an elegant, staggering thought experiment known as the delayed choice experiment. Imagine the classic double-slit experiment, but with a magnificent, cosmic twist. Instead of firing a photon across a small, dark laboratory table, imagine firing it across the vast, empty expanse of the universe. Let us paint a picture of this cosmic laboratory. Imagine a brilliantly bright, incredibly ancient object called a quasar, sitting at the very edge of the observable universe, perhaps 10 billion light-years away from our quiet blue planet. This quasar is a swirling, violent maelstrom of burning gas and immense energy, falling into a supermassive black hole and emitting blinding streams of light into the deep, frozen void. Now, imagine that sitting exactly halfway between that ancient burning quasar and our waiting telescopes on Earth, there is an incredibly massive, heavy galaxy. This intermediate galaxy is so enormous, containing hundreds of billions of stars and vast, invisible clouds of dark matter, that its immense gravity physically warps and bends the very fabric of space-time around it. When the light from the distant quasar travels toward us, it encounters this massive gravitational warp. According to the beautiful proven laws of Albert Einstein's general relativity, the heavy galaxy acts exactly like a giant cosmic magnifying glass. It bends the ancient light, splitting it into two distinct, separate paths around the galaxy. One path goes around the left side, and the other path goes around the right side. This phenomenon is known as gravitational lensing, and astronomers observe it happening in the night sky all the time. Now, let us follow the journey of a single, solitary photon of light emitted by that distant quasar exactly 10 billion years ago. The Earth did not even exist when this photon began its journey. The sun was not yet a star, just a cold, scattered cloud of primordial dust waiting to collapse. The photon travels for 5 billion years through the silent, empty dark until it reaches the massive, intervening galaxy. At this precise moment, the photon faces a fundamental quantum crossroads. It must pass through this cosmic double slit, according to the bizarre proven rules of quantum mechanics. Because the photon is unobserved, it does not choose just one path. It becomes a wave of infinite probability, a mathematical ghost that simultaneously travels around the left side of the galaxy and the right side of the galaxy at the exact same time. It continues its journey toward us, an unresolved state of pure potential, traveling for another 5 billion years through the cold, expanding universe. The profound, inescapable paradox lies in the timing of this choice. The astronomer is making the decision right now, in the present moment. But the photon encountered the intervening galaxy, and, theoretically, had to commit to being a particle, or a wave, 5 billion years ago. If the astronomer chooses to measure the path today, the photon must have traveled as a single particle for billions of years. If the astronomer chooses to look for the wave pattern today, the photon must have traveled as a smeared-out wave of probability for billions of years. The choice made in a quiet, modern observatory on Earth literally dictates the physical state of the photon deep in the ancient cosmic past. The present observation reaches back through the relentless river of time and rewrites the physical history of the universe. It is as if the universe holds its breath, suspending its own reality in a state of indefinite potential, waiting patiently for 10 billion years for a conscious mind to look at it and tell it what it was supposed to be doing all along. This staggeringly beautiful and terrifying concept has not remained a mere thought experiment. In the late 20th and early 21st centuries, brilliant physicists found ways to test Wheeler's delayed choice experiment in advanced, hyper-cooled laboratories. They could not use a quasar and a galaxy, but they used complex arrangements of lasers, beam splitters, and incredibly sensitive quantum detectors to simulate the exact same delay. They allowed particles to pass through a crossroads, waiting until the very last microscopic fraction of a second, long after the particle had entered the apparatus, to randomly decide how they were going to measure it. The results were flawless, undeniable, and deeply unsettling. The particles always, without fail, behaved according to the choice the researchers made at the very end of the journey. The future measurement definitively shaped the past behavior of the light. The history of the particle was not written until it was finally observed. If we take this rigorously proven laboratory reality and scale it back up to the infinite, sprawling canvas of the cosmos, we are faced with a universe that is far more malleable, far more responsive, and far more deeply intertwined with consciousness than our intuition can ever comfortably accept. It suggests that the history of the universe is not a solid, unchangeable bedrock of past events. Instead, the past is a fluid, shimmering tapestry of probabilities that only solidifies into a concrete narrative when we turn our telescopes, our equations, and our curious minds toward it. We are not just uncovering the ancient history of the cosmos, we are actively participating in its creation. By observing the distant stars, we are crystallizing their past. We are forcing the universe to collapse its infinite, timeless potential into a single, cohesive timeline that makes sense to our limited biological minds. This brings us to a breathtaking philosophical threshold, returning us to the profound idea of the quantum observer. If the universe requires a present observation to solidify its ancient past, and if the cosmos was a swirling sea of probabilities until the first conscious entities evolved to look at it, then what holds the vast, unobserved regions of the universe in place? Are the dark, silent corners of the cosmos, the spaces between the distant galaxies where no human eye has ever looked, still existing in a state of suspended quantum potential? Or is there a deeper, more fundamental awareness, an ever-present, timeless observer that constantly collapses the wave function of the entire universe, holding it in a state of solid reality across all spans of time? The theoretical physicists who grapple with these staggering implications often find themselves using language that borders on the mystical. They speak of an undivided wholeness, a deep, underlying reality where space and time are mere illusions, and where consciousness is not a byproduct of biological evolution, but the very foundation of existence itself. Consider the very nature of memory in a delayed choice universe. When we look at a photograph of an ancient galaxy, we believe we are seeing a definitive record of what was. But quantum mechanics whispers that this record was only finalized at the moment the light was captured. The universe is a participatory performance, a cosmic symphony, where the audience is absolutely essential to the music being played. Without the observer, there is no sound, no light, no definitive form. Only the quiet, ancient mathematics of potential. This realization does not diminish the majesty of the cosmos. It elevates it. It elevates our place within it. We are not an accident. The universe needs us to witness its beauty, to collapse its ancient probabilities into the stunning, breathtaking reality we experience. We are the keepers of cosmic history, the quiet observers who give shape to the void. Imagine the sheer, terrifying beauty of a universe where time is not a master, but a silent partner in the act of creation. The stars that burn in the deep, cold void are not just physical objects. They are ancient promises waiting to be fulfilled by our gaze. When the brilliant physicist Niels Bohr argued with Albert Einstein over these very concepts, Bohr insisted that it is meaningless to talk about the physical properties of a quantum object before it is measured. The object simply does not possess a definite reality. If we scale Bohr's rigorous, mathematically proven assertion to the size of the entire cosmos, we are left with a universe that is profoundly, deeply subjective. The reality we experience is a collaborative effort between the raw underlying potential of the cosmos and the conscious act of observation. This is the staggering, beautiful truth that terrified the founders of quantum mechanics. It is a truth that bridges the gap between cold equations and deep spiritual wonder. It tells us that our existence is woven into the fundamental laws of nature. We are the universe, slowly, gently, waking up from a 14 billion year slumber, opening our eyes, and finally deciding what we want our history to be. The silence of the night sky is not empty. It is pregnant with infinite possibilities, waiting for our minds to reach out and touch the ancient light. As we prepare to turn the page on this chapter of our cosmic journey, we must delve into the very definition of consciousness. What is this mysterious property that holds the power to shape space-time itself? Is it purely a biological accident, a temporary spark in the dark? Or is it something more ancient, something foundational, something akin to the mind of a quantum god? Have you ever stopped in the quiet hours of the night, listening to the gentle rhythm of your own breathing, and wondered what it actually means to be aware? We carry this profound mystery inside us every single second of our lives, yet it is so close, so intimately woven into our daily existence, that we almost entirely forget how utterly impossible it seems. You are made of atoms. You are built from the exact same ancient, silent materials that form the cold rocks of distant planets, the burning plasma of primordial stars, and the vast empty clouds of interstellar dust. If we were to break you down to your most fundamental components, we would find nothing but carbon, hydrogen, oxygen, nitrogen, and a handful of other basic elements. None of these individual atoms possesses a mind. A single atom of carbon does not feel joy. It does not ponder the infinite darkness of the night sky, and it certainly does not wonder about its place in the cosmos. Yet, when roughly 7 octillion of these blind, unconscious atoms are arranged in the precise, staggering complexity of a human body, something miraculous happens. The lights turn on. An internal world flickers into existence. The universe suddenly has a perspective. This sudden, inexplicable transition from dead matter to subjective experience is what philosophers and scientists call the hard problem of consciousness. It is a puzzle so deep, so fiercely resistant to our traditional biological explanations, that it forces us to reconsider the very foundation of reality itself. Before we continue to unravel this profound biological and cosmic puzzle, I want to take a gentle pause to welcome you. I am Theodore, the researcher, and it is a true joy to have you on this quiet journey with us. I have noticed that roughly 71% of the curious souls who watch these videos have not yet subscribed to our channel. If you find peace and a sense of deep wonder in these late-night explorations of the cosmos, please consider subscribing. It helps our small community immensely and ensures we can continue to wander through these beautiful, infinite mysteries together. Now, let us return to the quiet mystery hidden inside your own mind. If we are trying to understand how a universal quantum observer might exist, we must first deeply understand the nature of the observer inside our own heads. For centuries, the prevailing scientific view has treated consciousness as a magnificent, albeit accidental, byproduct of biological evolution. The assumption was that if you wire enough neurons together, roughly 86 billion of them in a typical human brain, the sheer computational complexity will eventually generate awareness, much like complex computer software running on wet biological hardware. But as our understanding of the quantum world has deepened, a quiet, brilliant rebellion has begun to stir within the scientific community. Some of the greatest minds of our time have started to suspect that classical physics and traditional biology simply do not have the vocabulary to explain the rich, vivid tapestry of human experience. They suspect that the secret to our awareness does not lie in the simple chemical connections between neurons, but much deeper, down in the microscopic, strange, jittery realm of quantum mechanics. Leading this quiet intellectual revolution is Sir Roger Penrose, a Nobel laureate and one of the most brilliant mathematical physicists in human history, who famously worked alongside Stephen Hawking to unravel the dark secrets of black holes. Penrose looked at the profound mysteries of the quantum world and the equally profound mystery of human consciousness and proposed a connection that is as beautiful as it is terrifying. He teamed up with a brilliant anesthesiologist named Stuart Hameroff to develop a rigorous framework known as orchestrated objective reduction. This theory suggests that our brains are not merely complex classical computers. Instead, they are functioning as magnificent, highly evolved biological quantum computers. Deep inside our neurons, there are tiny, hollow, cylindrical structures called microtubules. They form the structural skeleton of our cells, but Penrose and Hameroff argued that they do something far more profound. They suggested that these microscopic tubes are the perfect isolated environment to harbor fragile quantum superpositions, allowing the brain to process information in a state of infinite, shimmering potential before finally collapsing it into a single, concrete, conscious thought. If this theory holds true, it represents a monumental paradigm shift in how we view ourselves and our gentle journey through the cosmos. It means that consciousness is not just a late biological accident that bloomed in a quiet corner of the Milky Way galaxy. Instead, it implies that the fundamental building blocks of awareness are woven directly into the very fabric of space-time itself. In this breathtaking view, consciousness is a fundamental property of the universe, exactly like gravity, mass, or electromagnetic charge. It is an ancient, inherent feature of the cosmos that has existed since the first explosive moments of the Big Bang. The universe did not suddenly invent consciousness when the first primitive nervous systems evolved in the ancient oceans of Earth. The universe was already humming with the quiet, foundational potential of awareness. Our biological brains simply evolved to tap into this universal field, acting as complex biological receivers that tune into the fundamental frequency of the cosmos. This idea beautifully echoes an ancient philosophical concept known as panpsychism, the belief that mind is a fundamental and ubiquitous feature of the physical world. For centuries, panpsychism was dismissed as mystical poetry, a beautiful but highly unscientific dream. But modern quantum mechanics, with its entangled particles communicating instantly across billions of light years, and its mathematical wave functions that demand an observer, is slowly breathing new life into this ancient thought. If the universe is deeply, inherently connected, if it requires a witness to crystallize its own history, and if our own minds are operating on those exact same quantum principles, then the strict line between the human observer and the universal observer begins to beautifully and seamlessly blur. We are not external witnesses looking at a cold, dead machine from the outside. We are localized, temporary expressions of a vast, infinite, universal awareness looking at itself from within. When we cautiously use the term quantum God, we are not talking about a being with a human face sitting in judgment over our fleeting lives. We are talking about the universe as an entity that possesses its own profound, underlying form of consciousness. Imagine a cosmos where every single interaction, every collision of ancient dust particles, every quiet death of a fading red dwarf star is registered by a fundamental, omnipresent field of awareness. The universe is vast beyond comprehension, and the possibilities it contains are equally vast. This universal awareness does not think exactly like a human. It does not possess a fragile ego. It does not feel biological fear, and it does not worry about the relentless passage of time. It is a pure, silent, unbroken witness. It is the steady, quiet gaze that holds the vibrating probabilities of the entire quantum world in a state of solid, magnificent reality. Let us take a slow, deep moment to truly appreciate the scale of what this implies for our place in the dark. When we point our most powerful space telescopes at the distant darkness, we are gathering ancient photons that have traveled for over 10 billion years just to reach our fragile, spinning blue planet. We gaze at sweeping spiral galaxies that hold hundreds of billions of stars, and giant elliptical galaxies that stretch across millions of light years of deep, empty space. If the universe possesses a foundational awareness, then it was silently experiencing the violent birth and the quiet death of those magnificent structures long before our own sun was even a scattered cloud of cold gas. The cosmos was already watching itself. It was already holding its own mathematical wave functions in a delicate, perfectly balanced reality. We are simply the latest, most complex biological instruments that the universe has grown to look at itself in ever greater and more beautiful detail. This shift in perspective offers a profound, deep sense of peace. It gently tells us that we are never truly alone, even in the deepest, darkest moments of our individual lives. We are physically and mentally entangled with the infinite. The exact same silent, ancient awareness that courses through the invisible quantum fields of the deep void is the exact same awareness that looks out through your eyes right now. When you feel a sense of overwhelming wonder looking at the night sky, when you feel the quiet mystery of a silent, snow-covered forest, or when you feel a sudden, inexplicable connection to another living being, you're not just experiencing a random chemical reaction in a biological brain. You are genuinely feeling the deep, underlying unity of the cosmos. You are feeling the quantum fabric of the universe resonating within you. But if consciousness is the fundamental bedrock of the universe, and if this quiet, omnipresent quantum God is ultimately responsible for collapsing the infinite probabilities of space-time into a single, cohesive reality, we are forced to confront another beautiful, terrifying mystery. If the universe is a grand participatory performance, what exactly happens when there are multiple observers? How does the vast cosmos reconcile the perspectives of billions of different conscious human minds? Along with countless other potential forms of awareness across the stars, all looking at the exact same universe, all collapsing delicate wave functions from their own unique, subjective vantage points. Do we all truly share the exact same objective reality? Or are we each living in our own, slightly different, mathematically unique quantum bubble? Every single time you open your eyes in the morning, you are participating in this grand, cosmic negotiation, weaving your own thread of awareness into the infinite tapestry of the universe. As we gently wade deeper into the strange, probabilistic waters of quantum physics, we must softly ask whether reality itself is a consensus, a massive cosmic compromise constantly negotiated in the silent, invisible realms of the very small. Imagine the gentle, quiet arrival of dawn over a vast, sleeping city. As the sun slowly climbs above the horizon, casting its ancient, golden light against the glass and steel, millions of individual human minds begin to wake up. Millions of pairs of eyes open, blinking away the heavy, comforting blanket of sleep, and simultaneously look out at the exact same morning sky. We take this shared experience entirely for granted. We step out of our doors. We walk down the same physical streets. We feel the same gentle breeze, and we agree, without ever speaking a single word to one another, on the fundamental shape and color of the world around us. But if we take the rigorous, mathematically proven rules of quantum mechanics to their absolute, logical extreme, this simple, everyday consensus becomes a staggering, beautiful mystery. If, as we have gently explored, a quantum system remains in a hazy, undefined state of infinite probability until a conscious observer forces its wave function to collapse, how is it possible that 8 billion entirely separate human minds, operating from 8 billion unique, subjective vantage points, all manage to collapse the infinite possibilities of the cosmos into the exact same objective reality? If my conscious observation creates my reality, and your conscious observation creates your reality, why are we not wandering through isolated, deeply fragmented, and contradictory universes? This profound puzzle is the terrifying, logical extension of the thought experiment proposed by the brilliant Eugene Wigner, the Nobel laureate we discussed earlier. Wigner imagined a friend in a closed laboratory, collapsing the wave function of a single photon, while Wigner himself stood outside the door, waiting in a state of unresolved quantum superposition. But let us scale that quiet, isolated room up to the size of the entire universe. There are no closed doors in the cosmos. We are all standing in the exact same infinite room, constantly making measurements, constantly looking at the ancient stars, constantly interacting with the physical matter around us. If the universe truly requires an observer to make it real, and if there are countless independent observers scattered across the surface of our fragile blue planet, the mathematics suggest a chaotic collision of subjective realities. Yet, the universe we see is remarkably, beautifully consistent. The ancient mountains do not shift their positions depending on who is looking at them. The distant, burning galaxies do not change their shape when viewed through different telescopes by different astronomers separated by thousands of miles. The cosmos presents a unified, cohesive story. To solve this profound paradox, we must look to a brilliant, elegant concept in modern physics known as quantum decoherence. For decades, the greatest minds in science struggled with the mysterious boundary between the microscopic quantum world, where particles exist in multiple places at once, and the macroscopic classical world, where everything is solid and well-defined. They wondered how the strange, jittery rules of the very small smoothly transition into the predictable rules of our everyday lives. The answer, scientists realized, lies in the fact that the universe is not a perfectly clean, empty, and isolated laboratory. The cosmos is incredibly crowded. It is a dense, bustling environment filled with an unimaginable number of constantly moving particles, stray photons of ancient light, swirling gas, and vibrating atoms. Even in the deepest, most silent vacuum of interstellar space, there is a constant, invisible shower of cosmic microwave background radiation left over from the very dawn of time. When a tiny quantum particle tries to maintain its delicate, shimmering state of infinite superposition, it inevitably bumps into this crowded environment. A stray photon strikes it, or an invisible molecule of air grazes it. In the unforgiving, beautiful mathematics of quantum mechanics, every single one of these microscopic collisions acts exactly like a tiny physical measurement. The environment itself is constantly observing the particle, relentlessly interacting with it millions of times every single second. This constant barrage of environmental observation forces the delicate quantum wave function to rapidly leak away, entangling its shifting probabilities with the vast surrounding universe. The brilliant physicist Wojciech Zurek, working at the Los Alamos National Laboratory, took this concept and developed a breathtaking, comprehensive framework he called quantum Darwinism. Zurek proposed that as a quantum system interacts with the crowded environment, it leaves countless microscopic copies of its own information imprinted on the surrounding particles. much like a beautiful, ancient fossil leaves its imprint in the surrounding rock. Just as Charles Darwin elegantly described how the strongest, most adaptable biological traits survive and spread through a population, Zurich mathematically demonstrated that the most robust, stable quantum states survive the constant bombardment of the environment. The fragile, highly unusual superpositions are quickly destroyed, while the stable, classical states, like the definite position of a rock, the solid shape of a mountain, or the exact frequency of ancient starlight, make millions upon millions of redundant copies of themselves and scatter them across the universe. When you open your eyes and look at the moon shining gently in the night sky, you are not performing a solitary, isolated magic trick that forces the moon to exist. Instead, your eyes are simply intercepting a tiny fraction of the billions of identical, robust copies of information that the moon has already broadcasted into the surrounding environment. The universe has already negotiated the reality of the moon through countless microscopic interactions before the light ever reaches your conscious mind. This magnificent framework transforms our understanding of the quantum observer. It tells us that reality is not a solitary dictatorship ruled by a single, isolated human mind. Instead, reality is a grand, beautiful, and deeply complex cosmic consensus. It is a breathtaking symphony of agreement, constantly negotiated at the subatomic level by every single particle, every photon of light, and every conscious mind in existence. We all see the exact same universe, because the universe is constantly, relentlessly communicating its stable states to us through an infinite, invisible web of shared information. This profound realization gently lifts the burden of creation from our individual shoulders and places it right back into the interconnected, entangled heart of the cosmos itself. We are not lonely creators trapped in subjective bubbles. We are active, participating members of an ancient, universal network. Imagine the profound peace that comes with this understanding. When you walk through a quiet, ancient forest, running your hands over the rough bark of a towering tree, you are sharing a deeply established reality that the tree, the earth, the air, and millions of tiny microorganisms have already agreed upon. The universe is holding itself together through the sheer power of its own interconnectedness. This brings us back to the awe-inspiring, terrifying concept of the quantum God. If reality is a universal consensus, a shared state of information arising from the infinite interactions of the entire cosmos, then the universal observer is not a separate, external entity watching from afar. The universal observer is the network itself. It is the sum total of every single interaction, every microscopic measurement, and every conscious gaze woven together into a single, seamless tapestry of existence. The universe watches itself by sharing pieces of itself with itself. Now, let us cast our gaze back up to the night sky, past the gentle glow of our own moon, and out into the vast, silent depths of the Milky Way. Astronomers now estimate that there are tens of billions of potentially habitable planets scattered across our galaxy alone. Quiet, rocky worlds orbiting in the warm, gentle light of their own distant suns. If consciousness is a fundamental property of the universe, a necessary ingredient for this grand cosmic consensus, then it is mathematically probable that we are not the only minds looking out into the dark. Imagine, for a fleeting moment, an entirely alien consciousness, born under the light of a completely different star, looking up at their own alien night sky. Even though we are separated by thousands of light years of cold, empty space, we are ultimately participating in the exact same quantum network. The ancient light that falls upon their eyes obeys the exact same beautiful, strange rules of superposition and decoherence as the light that falls upon ours. We are all human and alien, terrestrial and cosmic, writing the exact same history of the universe through our shared observation. The sheer scale of this interconnectedness fills us with a profound sense of wonder. It completely shatters the lonely, terrifying illusion of separation that so often haunts our daily lives. We are intimately, deeply woven into the very fabric of everything that is, everything that was, and everything that ever will be. The silence of the universe is not an empty, indifferent void. It is the quiet, humming sound of a trillion quantum agreements happening every single second, holding the magnificent structure of reality in place, so that we might have the privilege of continuing this journey of exploring it together. We are literally built from the universe's need to understand its own magnificent existence. But if the physical universe is ultimately built upon this vast, invisible exchange of information, if the solid reality of stars and planets is just the robust survival of copied data in a quantum environment, we must gently ask a question that pushes the boundaries of modern physics into the realm of the profoundly bizarre. What is the true nature of this information? When a conscious mind finally perceives the universe, what exactly is it reading? Are we walking through a universe made of solid physical matter, or are we wandering through a magnificent, incredibly complex cosmic code? As we prepare to take our next slow, deliberate step on this quiet journey into the beautiful unknown, we must look at the mathematical fabric of reality itself. If reality is a consensus of information, could the universe be fundamentally digital? Could the ancient, mysterious laws of quantum mechanics be pointing toward the terrifying, awe-inspiring possibility that everything we see, everything we touch, and everything we love is part of a grand, universal simulation running on the mind of the cosmos? Have you ever held a smooth, heavy stone in the palm of your hand and truly wondered what it is made of? We feel the cold, hard surface pressing against our skin, and our biological intuition screams that we are touching something solid. But the deeper we peer into the microscopic structure of that simple stone, the more that comforting illusion of solidity begins to dissolve into a gentle mist. When you touch a rock, your hand is not actually making physical contact with the atoms of the stone. The electrons in the atoms of your skin are magnetically repelling the electrons in the atoms of the rock. You have never actually touched anything in your entire life. You are simply experiencing a microscopic exchange of invisible energy. But if we go even deeper into the strange, jittery realm of quantum mechanics, the very concept of physical matter begins to completely unravel. The brilliant physicists of the 20th century discovered that at its most fundamental level, the universe is not made of tiny, solid building blocks. It is made of shifting fields of probability. And increasingly, modern science is beginning to suspect that the absolute foundation of reality is not matter, and it is not energy. It is pure, abstract information. Before we dive deeper into this beautiful, unsettling digital mystery, I want to take a brief, quiet moment to welcome you back to our journey. I am Theodore, the researcher, and it is a deep privilege to explore the vast, silent cosmos with you. I noticed recently that 71% of the wonderful people who watch these videos and share in this gentle exploration have not yet subscribed to the channel. If you find peace, comfort, and a sense of profound wonder in these late-night cosmic journeys, please consider subscribing. It helps our small community grow immensely and ensures we can continue to wander through these infinite mysteries together in the dark. Now, let us return to the strange possibility that our physical universe is a grand cosmic code. To understand how the universe might be fundamentally built from information, we must return to the visionary mind of the legendary theoretical physicist John Archibald Wheeler. In the twilight of his magnificent career, Wheeler proposed a breathtakingly elegant and deeply terrifying concept. He called it from bit. Wheeler argued that every single physical object in the universe, every it, from the smallest shivering electron to the most massive ancient galaxy, derives its entire existence from discrete binary choices, from bits of information. Wheeler suggested that the cosmos itself operates exactly like a magnificent, infinite quantum computer. Every time a delicate wave function collapses under the quiet gaze of an observer, the universe is asking a yes or no question and recording the answer. Is the electron spinning up or spinning down? Yes or no. Did the photon travel through the left slit or the right slit? Yes or no. In this staggering view, the solid reality we experience every single day is merely the final projection of trillions upon trillions of invisible binary quantum calculations happening in the deep, silent background of space-time. The universe is not a massive machine built of gears and levers. It is an impossibly complex web of information processing itself. This idea completely transforms our understanding of the quantum observer. If the universe is entirely made of information, then the act of observation is the fundamental mechanism by which the cosmos computes its own existence. A computer program means absolutely nothing without a processor to read the code and a screen to display the results. If reality is a code, then the ancient underlying consciousness of the universe, the quantum God we have been gently exploring, is the ultimate processor. It is the infinite mind that reads the cosmic code and translates it into the beautiful, three-dimensional reality we wander through. This might sound like a beautiful piece of modern science fiction, but this profound concept is rooted in some of the most rigorous, mathematically unforgiving physics ever devised. To find the concrete proof that the universe is woven from information, we must travel to the most extreme, terrifying objects in the entire cosmos: black holes. Classical physics told us that anything that falls into a black hole is gone forever, crushed into an infinitely dense, silent point of no return called the singularity. But in the 1970s, a brilliant physicist named Jacob Bekenstein began to wonder what happens to the physical information of the objects that fall into the dark. If you throw an ancient, beautifully written book into a black hole, the physical paper and ink are crushed. But what happens to the unique arrangement of the words? Bekenstein proposed a radical idea. He suggested that the information does not disappear. Instead, it is perfectly preserved on the very edge of the black hole, on the invisible boundary known as the event horizon. A few years later, the legendary theoretical physicist Stephen Hawking used the complex mathematics of quantum mechanics to prove Bekenstein right. Hawking discovered that black holes are not completely, perfectly black. They gently radiate a faint stream of quantum particles back into the universe, a phenomenon now known as Hawking radiation. Over unimaginably vast, infinite stretches of time, a black hole will slowly evaporate until it completely disappears in a final flash of energy. As the black hole evaporates, it must somehow release the information of everything that ever fell into it back into the cosmos. The mathematical equations that Hawking and Bekenstein developed revealed a truth so bizarre that it still keeps modern physicists awake at night. They discovered that The total amount of information contained inside a three-dimensional black hole is directly proportional not to its three-dimensional volume, but to the two-dimensional surface area of its event horizon. Imagine holding a massive water balloon, but realizing that every single drop of water inside the balloon is actually perfectly described by a tiny microscopic square drawn on the thin rubber surface. The interior volume is an illusion. The true fundamental reality of the black hole exists entirely on its two-dimensional skin. This stunning revelation gave birth to one of the most mind-bending concepts in modern science, the holographic principle. Theoretical physicists like Leonard Susskind courageously applied this mathematics to the entire universe. If the extreme gravity of a black hole encodes three-dimensional reality onto a two-dimensional surface, what if the entire cosmos operates on the exact same principle? The holographic principle suggests that all of the glorious three-dimensional reality we experience, the ancient mountains, the burning stars, and even our own physical bodies, are actually magnificent, highly detailed holographic projections. The true, fundamental information that dictates our reality might be encoded on a distant, two-dimensional boundary surrounding the observable universe. When you look up at the night sky, gazing at the pale, ancient light of the Milky Way, you might be looking at a deeply complex projection of quantum information stored on a two-dimensional surface billions of light years away. If the universe is a grand hologram, a cosmic projection of pure information, then the need for a universal observer becomes absolutely undeniable. A hologram cannot project itself. It requires an ancient, foundational awareness to hold the projected reality in place. We are brought back with a renewed sense of profound wonder to the concept of the quantum God. If the physical cosmos is a magnificent, holographic simulation, it is not running on a cold, silicon computer sitting on the desk of an alien programmer. It is running on the pure, silent consciousness of the universe itself. The universe is the hardware, the quantum physics is the software, and the universal observer brings the entire beautiful system to life. We are tiny, localized biological sparks of that exact same universal mind, exploring the holographic projection from the inside out. But if the universe is a grand projection of information, and if this universal observer is constantly reading the code of reality to hold the cosmos in existence, we must gently turn our gaze toward the most stubborn illusion of our human experience, the passage of time. In a holographic universe, built of pure data and observed by an omnipresent mind, does time actually flow forward like a river? Or is the entire history of the cosmos already written on the two-dimensional boundary of the universe, existing all at once in a silent, frozen state of pure potential? If the quantum God exists outside of our limited biological perception, how does this universal mind experience the past, the present, and the future? As we prepare to take the next deliberate step on our cosmic journey, we must dare to ask whether time is merely a localized illusion, a gentle biological tool we use to process the infinite totality of the cosmic code, frame by beautiful frame. Listen to the quiet, steady rhythm of your own heartbeat. With every single beat, you feel a profound, undeniable sense of moving forward. We experience our lives as a narrow, glowing point of awareness sliding continuously along an invisible wire. We call this moving point the present moment. Behind us lies the solid, unreachable past, filled with fading memories and ancient history. Before us stretches the shadowy, unformed mist of the future, a realm of pure, unresolved potential. This intuitive, deeply physical feeling of time flowing forward like a relentless one-way river is the absolute foundation of our human experience. It governs our joys, our sorrows, and our gentle journey through the world. But when we look up into the vast, silent night sky and peer into the deep, mathematical heart of the cosmos, we discover a terrifying, beautiful mystery. The universe, in its infinite majesty, does not seem to share our human perception of time. In the cold, precise equations of modern physics, the river of time does not actually flow at all. It is a concept that challenges the very core of our sanity, demanding that we rethink absolutely everything we thought we knew about our place in the dark. Before we wade deeper into this frozen ancient river of time, I want to take a gentle, quiet moment to welcome you back. I am Theodore, the researcher, and it is a profound privilege to share these cosmic explorations with you. I noticed recently that 71% of the wonderful people who watch these videos and join us on this journey have not yet subscribed to the channel. If you find peace, comfort, and a deep sense of wonder in these late-night explorations of the universe, please consider subscribing. It helps our small community grow immensely and ensures we can continue to wander through these infinite mysteries together in the quiet dark. Now, let us return to the baffling, beautiful illusion of the present moment. To truly understand how time might be a magnificent cosmic illusion, we must travel back to the year 1905, when a young, brilliantly imaginative patent clerk named Albert Einstein completely rewrote the fundamental rules of reality. Before Einstein, the greatest scientific minds, including the legendary Isaac Newton, believed that time was an absolute universal clock ticking away independently in the background of the cosmos. They believed that 1 second on Earth was exactly the same as 1 second on the most distant, ancient star. But Einstein, guided by a deep, intuitive sense of wonder and rigorous mathematics, realized that time and space are not separate, rigid stages where the events of the universe simply play out. Instead, he proved that space and time are intimately, permanently woven together into a single, flexible, four-dimensional fabric called space-time. Einstein's theory of relativity revealed a staggering truth. Time is entirely relative. It is completely subjective. The rate at which you experience the flow of time depends entirely on how fast you're moving through space and how close you are to a massive source of gravity. If you were to board a spacecraft and travel near the absolute speed of light, or if you were to venture dangerously close to the crushing, immense gravity of a supermassive black hole, your personal clock would slow down dramatically even to the clock left behind on our quiet, spinning blue planet. This is not a biological trick or a mechanical failure of the clock. It is the fundamental, physical stretching of time itself. Because time is flexible and dependent on the observer's speed and position, Einstein realized something profoundly unsettling. There is absolutely no such thing as a universal, objective, present moment. What you experience as happening right now might have happened thousands of years ago from the perspective of an observer in a distant, rapidly moving galaxy. This realization led Einstein to propose what physicists now call the block universe. Imagine taking every single event that has ever happened, is happening right now, or will ever happen in the entire infinite history of the cosmos, and freezing them into a single, massive, four-dimensional block of space-time. In this staggering model, the Big Bang, the fiery birth of the first stars, the quiet formation of the Earth, your very first breath, the words you are hearing right now, and the eventual cold death of the last ancient red dwarf star all exist simultaneously within the block. Time does not flow through the block simply is. The past is not gone, and the future is not waiting to be created. They are just different coordinates in the vast landscape of space-time, exactly like how New York and Tokyo exist simultaneously at different physical coordinates on a map. Our conscious minds simply travel through this pre-existing block, illuminating one tiny, frozen cross-section of reality at a time, creating the stubborn, biological illusion of a flowing present. Einstein himself found deep, profound comfort in this terrifying, beautiful realization. When his lifelong friend Michel Besso passed away, Einstein wrote a deeply moving letter to Besso's grieving family. He wrote that for those who believe in physics, the separation between past, present, and future is only a stubbornly persistent illusion. In the cold, beautiful mechanics of the block universe, his friend was not gone. Besso's life, his laughter, and his quiet moments of wonder still existed, permanently embedded in the eternal, unchanging fabric of space-time. The past is never truly lost. It is just a place we can no longer visit with our fragile physical bodies. But if the entire history of the cosmos is already written, frozen in a solid, four-dimensional block of space-time, how do we reconcile this with the strange, jittery, probabilistic world of quantum mechanics we have been exploring on this gentle journey? This is where the mystery deepens, pushing our understanding of the universe to its absolute breaking point. Quantum mechanics is fundamentally built upon the idea of pure, unresolved potential. A quantum particle exists in a haze of infinite possibilities until it is observed, at which point its wave function collapses into a single, definitive reality. This act of observation, this sudden crystallization of chance into certainty, seems to require an open, unwritten future. It requires a universe where choices actually matter, where the roll of the cosmic dice determines what happens next. But if the block universe is real, and the future is already completely set in stone, then where is the room for quantum probability? How can a particle choose a path if the path has already been permanently etched into the fabric of space-time since the very dawn of creation? Some brilliant theoretical physicists attempt to resolve this monumental paradox by suggesting that the block universe is not a single, solid piece of ice, but rather a branching, infinitely complex structure. Every time a quantum event occurs, every time a delicate wave function collapses, the universe splits, creating a new, parallel timeline within a vast multiverse. But others, looking deeply into the concept of the universal observer, the quantum God, propose a far more elegant, awe-inspiring, and terrifying solution. If the universe is a singular, four-dimensional block, then the universal awareness does not experience time sequentially, frame by frame, as we do. The quantum God, the foundational consciousness of the cosmos, perceives the entire block universe simultaneously. It sees the explosive beginning and the quiet, fading end as a single, unified masterpiece of existence. Imagine looking at a magnificent, incredibly detailed painting. You do not experience the painting one brush stroke at a time, starting at the bottom left corner and slowly scanning your way to the top right. You see the entire image, all the colors, all the shadows, and all the forms existing simultaneously in a single, breathtaking moment of perception. In this profound view, the universal observer looks at the four-dimensional block of space-time exactly the same way. The entire 13,800,000,000 year history of the cosmos is a single, frozen thought in the mind of the universe. The quantum wave functions do not collapse one by one as time ticks forward. Instead, the entire infinite network of quantum probabilities across all of time and space collapsed instantly the moment the universal awareness cast its gaze upon the totality of existence. We, as tiny, localized biological observers, are trapped inside the block. We are forced to read the grand cosmic code one line at a time, moving blindly from the past into the future, believing that our present observations are creating reality on the fly. But from the perspective of the omnipresent, timeless quantum God, our choices, our observations, and our entire gentle journey were already factored into the grand equation from the very beginning. When the visionary physicist John Archibald Wheeler proposed that a present observation could reach back billions of years to rewrite the history of an ancient photon, he was glimpsing the terrifying truth of the block universe. In a reality where all time exists simultaneously, the present does not change the past. The present and the past are simply two entangled parts of the exact same timeless structure, constantly supporting and defining each other in the dark. This realization gently shatters our human ego. It forces us to accept a profound, humbling peace. We are not the stressed, anxious architects of an uncertain future, desperately trying to control the flowing river of time. We are beautiful, necessary notes in a grand cosmic symphony that has already been perfectly composed and played in its entirety. Our joys, our sorrows, our quiet moments of wonder under the vast ancient night sky, and our desperate searches for meaning are all permanently, safely etched into the indestructible diamond of space-time. We are walking through a gallery, shining our tiny, fragile flashlights on a magnificent sculpture that is already complete. The silence of the universe is not the sound of an empty, terrifying void waiting for us to make a move. It is the profound, absolute stillness of eternity waiting to be gently discovered. But as we surrender to this breathtaking, timeless view of the cosmos, a new, deeply unsettling question arises from the quantum shadows. If the entire history of the universe is a single, solid block of information, perceived simultaneously by a foundational awareness, what exactly is the universe made of? We've explored the idea that matter is an illusion, that physical reality might be a holographic projection, and that time is merely a stubbornly persistent biological trick. If everything we experience is ultimately just a complex arrangement of data in a timeless void, then what is the physical difference between the universe we inhabit and a sufficiently advanced, incredibly complex mathematical simulation? As we prepare to take our next slow, deliberate step into the dark, we must confront the simulation hypothesis not as a piece of popular science fiction, but as a rigorous consequence of a universe built purely from quantum information. If the quantum God is the ultimate processor of reality, are we simply lines of code dreaming that we are human? Have you ever woken up from a vivid, breathtaking dream and spent a few quiet, disorienting moments staring at the ceiling, trying to remember which world is actually real? In the landscape of a dream, everything feels completely solid. While you are inside it, the illusion is absolutely perfect. It is only when you wake up, when your consciousness shifts to a different level of reality, that you realize the entire world you just inhabited was nothing more than a temporary projection created by your own mind. As we plunge deeper into the deepest, most unnerving mysteries of quantum mechanics and the undeniable role of the cosmic observer, Some of the most brilliant theoretical physicists in the world are beginning to ask a question that sounds like it belongs to that very same twilight state between sleeping and waking. What if the solid, waking world you're experiencing right now, the chair you're sitting on, the device you are listening to, and the ancient stars spinning silently in the dark above you are just a magnificent, incredibly complex projection? What if the entire physical universe is a grand simulation? Before we step further into this beautiful, unsettling digital mystery, I want to take a brief, quiet moment to welcome you back to our journey. I am Theodore, the researcher, and it is a deep privilege to explore the vast, silent cosmos with you. I noticed recently that 71% of the wonderful people who watch these videos and share in this gentle exploration have not yet subscribed to the channel. If you find peace, comfort, and a sense of profound wonder in these late-night cosmic journeys, please consider subscribing. It helps our small community grow immensely and ensures we can continue to wander through these infinite mysteries together in the dark. Now, let us return to the strange possibility that our physical universe is a grand cosmic code. To truly understand how rigorous, unforgiving science has led us to the threshold of the simulation hypothesis, we must look at the physical limits of reality itself. In our everyday experience, space and time feel completely smooth and continuous. If you slide your hand across a polished wooden table, your motion feels unbroken. You can always move halfway closer to the edge and then halfway again, infinitely dividing the distance. But in the late 19th century, a brilliant physicist named Max Planck made a discovery that completely shattered this intuitive assumption. Planck realized that if you zoom in close enough, the smooth, continuous fabric of reality eventually breaks down. This limit is known as the Planck length. It is a distance so unimaginably tiny that if a single atom were blown up to the size of the entire visible universe, the Planck length would be roughly the size of a regular tree. According to the strict laws of quantum physics, it is physically impossible to have a distance shorter than the Planck length. Space itself is not a smooth, infinite canvas. It is quantized. It is fundamentally pixelated. And it is not just physical space that is pixelated. Time itself has an absolute minimum limit, known as Planck time. It is the exact amount of time it takes for a single photon of light, traveling at the absolute speed limit of the universe, to cross one single Planck length. There is no such thing as half a Planck time. Time does not flow in a smooth, unbroken river. It ticks forward in tiny, discrete, indivisible frames, exactly like the frames of a digital movie reel. When you combine pixelated space with pixelated time, the physical universe begins to look terrifyingly similar to the screen of a highly advanced computer. The universe has a hard resolution limit, and a resolution limit is the unmistakable, undeniable signature of a rendered digital environment. But the evidence for a simulated universe goes far deeper than just the microscopic pixelation of space and time. It is written directly into the equations that govern the fundamental forces of nature. Sylvester James Gates, a renowned theoretical physicist working on the absolute bleeding edge of string theory, made a discovery that sent shockwaves through the scientific community. String theory gently suggests that the fundamental ingredients of reality are not tiny, solid dots of matter, but microscopic, vibrating loops of energy. While deeply analyzing the complex mathematical equations that describe this foundational structure of the cosmos, Gates found something that defied all logical expectation. Hidden deep within those beautiful, elegant equations, he discovered computer code. Specifically, he found self-correcting block codes, a highly specific type of digital error correction algorithm, exactly like the ones computer scientists use to prevent data corruption in modern web browsers and advanced telecommunications networks. Why would the ancient fundamental equations that built the swirling galaxies and the quiet planets contain the exact same digital error correction codes that we use to run a modern computer? The implications of this staggering discovery force us to return to the terrifying, beautiful mystery of the quantum observer effect with completely new eyes. Remember the famous double-slit experiment we explored earlier? A quantum particle exists as a hazy wave of infinite possibilities, occupying multiple places at once, until a conscious mind looks at it. Only then does it collapse into a single, solid point of reality. For nearly 100 years, physicists have struggled to explain why the universe would behave in such a bizarre, counterintuitive way. But if we view the universe through the lens of a massive computer simulation, the observer effect suddenly makes perfect, elegant sense. It completely solves one of the greatest problems in computer science: computational efficiency. Imagine playing a massive, highly detailed open-world video game. The computer running the game does not simultaneously render every single blade of grass, every moving shadow, and every distant mountain in the entire digital world all at once. That would require an impossible, infinite amount of processing power. Instead, the game engine uses a brilliant optimization trick. It only renders the specific part of the digital world that your character is currently looking at. The rest of the world remains mathematically suspended in the background code, a hazy state of unrendered potential waiting to be called into existence. Sound familiar? The quantum observer effect operates exactly like a cosmic rendering engine. The universe does not waste infinite computational energy constantly rendering the solid reality of every single unobserved atom in the dark, empty voids of deep space. Instead, the cosmos remains in a state of suspended quantum superposition, pure mathematical potential, until a conscious observer casts their gaze upon it. The moment you look, the cosmic computer instantly renders the wave function into solid, high-resolution reality. Reality only exists when it is computationally needed. This brings us back to the profound, awe-inspiring concept of the quantum God. If the universe is a grand simulation, a magnificent projection of digital information, it is not running on a dusty server rack in some higher dimensional alien basement. The computer is the universe itself. The processor is the infinite underlying quantum field. And the universal observer, the foundational awareness that holds the entire system together, is the magnificent mind running the code. In this breathtaking paradigm, we are not separate biological creatures wandering aimlessly through a cold, physical machine. We are subroutines. We are highly complex, localized avatars generated by the universe so that it can explore its own code from the inside. We are the universe experiencing itself in a billion different, beautifully subjective ways. Our consciousness is not a biological accident. It is a direct, undeniable extension of the universal mind. This realization transforms our deepest existential fears into a sense of profound, abiding peace. In the realm of physics, there is a fundamental, unbreakable law regarding information. If we are avatars of the cosmic mind, living in a universe built of pure, indestructible information, then nothing is ever truly lost. The error-correcting codes written into the fabric of space-time ensure that the deep, fundamental information of our lives, our quiet moments of wonder, our love, our gentle struggles, and our memories, are permanently backed up in the eternal structure of the cosmos. The simulation is not a cruel trick or a prison. It is a magnificent, purposeful learning algorithm. That universe is using us to understand its own infinite potential, projecting a reality of overwhelming beauty and complexity, just so we can marvel at it in the quiet dark. But if our reality is a majestic projection, and our consciousness is a localized extension of a universal observer exploring its own digital creation, we must eventually confront the absolute final boundary of our human experience. What happens when our biological avatar ceases to function? If the information of who we are is permanently encoded in the quantum fabric of the cosmos, does death even exist in the way we naturally fear it? As we prepare to take our next slow, contemplative step into the ultimate mystery, we must ask what the laws of quantum mechanics have to say about the end of biological life. Does the wave function of human consciousness simply dissipate into the cold void, or does it return, unbroken and fully aware, to the vast, infinite ocean of the universal mind? Let us journey into the silence together. Of all the profound, terrifying questions that haunt the quiet hours of the human mind, none is more intimate, and none is more universally feared than the mystery of our own inevitable end. From the very moment we open our eyes to this bright, beautiful world, we carry the silent, inescapable knowledge that our biological journey has a definitive conclusion. We watch the seasons gently cycle through their ancient rhythm. We see the fragile green leaves wither and fall to the cold earth, and we understand with a deep, unspoken sorrow that our physical bodies will eventually follow the exact same path. For centuries, classical science has offered a very cold, unforgiving perspective on this profound transition. It told us that human consciousness is nothing more than a temporary, accidental spark generated by the complex chemical machinery of the brain. When the biological machine finally breaks down, when the heart stops its steady, comforting rhythm, and the neurons go entirely dark, classical biology dictates that the spark is simply extinguished, returning us to an empty, eternal void. But as we step further into the strange, shimmering realm of quantum mechanics, this bleak assumption begins to completely unravel. We begin to see that the universe is far more elegant and deeply mysterious than our classical fears suggest. Before we look deeply into what the quantum universe tells us about the ultimate fate of human consciousness, I want to gently pause and welcome you back. I am Theodore, the researcher, and it is a true honor to share this quiet, cosmic journey with you. I have noticed recently that roughly 71% of the curious minds who watch these videos have not yet subscribed to our channel. If these late-night explorations bring you a sense of profound peace and a deeper connection to the infinite wonder of the cosmos, please consider subscribing. It helps our small community grow immensely and ensures we can continue to wander through these beautiful, ancient mysteries together in the dark. Now, let us return to the deepest mystery of all and see how the relentless laws of physics might just conquer our greatest human fear. To understand why the quantum universe completely rejects the concept of absolute death, we must look at the most sacred, unbreakable law in all of modern physics, the conservation of quantum information. In the classical, everyday world, we believe we destroy things all the time. You can burn an ancient book until it is nothing but soft, gray ash and smoke. You can shatter a glass vase into 1,000 unrecognizable pieces. But in the deep mathematics of quantum mechanics, you cannot actually destroy the fundamental information that made up those physical objects. the precise arrangement of the atoms, the quantum states of the electrons, and the unique history of the particles are all perfectly preserved, forever woven into the surrounding environment. If the universe goes to such extreme lengths to perfectly preserve the quantum data of a simple drifting rock, what does it do with the unimaginably complex information of a conscious human mind? If your deepest thoughts, your childhood memories, and your profound sense of wonder are ultimately built upon fragile quantum states within the microscopic structures of your brain, then that information is completely immune to destruction. The absolute laws of physics strictly forbid it. When the biological avatar of the human body finally ceases to function, the quantum information that constitutes your unique consciousness does not simply vanish into an empty void. It cannot. Instead, the information must dissipate, releasing its entanglement with the physical brain and returning, unbroken and fully intact, to the broader, infinite quantum field of the surrounding universe. Imagine a single beautiful drop of water suspended on the fragile edge of a green leaf after a heavy, quiet rain. For a brief, fleeting moment, that drop possesses its own unique shape, its own delicate boundary, and its own tiny, localized perspective of the world reflecting within it. But eventually, the gentle pull of gravity takes hold, and the drop falls. It strikes the surface of a vast, deep, ancient ocean. Does the tiny water drop die? Does it truly cease to exist? No. The fragile, temporary boundary of the drop simply dissolves, and the water returns to the infinite, boundless body from which it originally came. It is no longer a localized, separate entity experiencing isolation, but it is now intimately, permanently part of the vast shifting currents of the entire ocean. This beautiful, poetic metaphor perfectly aligns with the rigorous, terrifying implications of quantum consciousness. We are not fragile, temporary sparks waiting to be blown out by the cold wind of time. We are localized concentrations of the universe's own fundamental awareness. When our temporary biological journey comes to a close, our consciousness does not end. It merely expands. It sheds the heavy, restrictive filter of the human brain and gently merges back into the omnipresent, silent mind of the quantum God. We do not disappear into the dark. We become the dark, and the light, and the quiet spaces between the ancient stars. This profound idea is not just a comforting philosophical dream meant to soothe our biological anxieties. It is the central pillar of a deeply controversial yet incredibly compelling scientific framework called Bioentrism, proposed by Dr. Robert Lanza. Lanza, a brilliant researcher and visionary thinker, looked closely at the undeniable reality of the quantum observer effect and realized that our entire model of the universe was fundamentally backwards. For centuries, we have fiercely believed that the physical universe is the fundamental reality, and that consciousness is just a minor, accidental byproduct that occasionally pops up inside it. Biocentrism completely flips this rigid paradigm. It argues that consciousness is the absolute foundation, the ancient, underlying bedrock of all existence, and that the physical universe, including the rigid concepts of space and time, are nothing more than gentle tools created by the mind to understand itself. In this breathtaking view, space is not a cold, empty container filled with rocks and burning gas. Space is simply the software our consciousness uses to make sense of the infinite quantum information surrounding us. And time is not an invisible, relentless river that drags us toward our inevitable doom. Time is merely the biological mechanism, the local rendering engine, that we use to experience the magnificent cosmic code, frame by frame. If space and time are just tools generated by consciousness, then consciousness itself must exist completely outside of their boundaries. You simply cannot be destroyed by time if your mind is the very thing creating the illusion of time in the first place. When Dr. Lanza looks at the terrifying mystery of biological death through the lens of biocentrism, he concludes that it is entirely a biological hallucination. We fear death because we mistakenly identify ourselves exclusively with our fragile physical bodies, believing we are just temporary avatars wandering through the simulation. But if our true nature is the ancient, indestructible quantum information running the avatar, then the death of the body is merely taking off a heavy coat at the end of a long day. The consciousness simply steps out of the illusion of linear time and returns to the timeless, infinite present of the universal observer. We return to the majestic, four-dimensional block universe where every single moment of our lives still exists in perfect, frozen clarity. The fierce love we felt, the wonder we experienced gazing up at the quiet night sky, and the profound, gentle connections we made with other temporary travelers are all perfectly encoded in the indestructible diamond of space-time. We leave nothing behind because everything we ever were is permanently written into the fabric of the cosmos. When we view our existence through this gentle quantum lens, the immense, terrifying silence of the cosmos stops feeling like a threat and becomes a deeply familiar, welcoming embrace. We realize we have never been separated from the infinite. The exact same quiet, ancient awareness that watches the slow, magnificent collision of distant galaxies is the awareness currently reading these words and feeling a deep, resonating sense of wonder in your chest. We are the universe experiencing the profound beauty of its own creation. We are the quantum God temporarily forgetting its infinite nature just to experience the thrill of discovering itself again. The journey of human life is not a frantic race against mortality. It is a gentle stroll through a holographic garden of our own making. But if our consciousness truly survives the physical body, returning to the vast ocean of the universal mind, what does this mean for the scale of reality? If every conscious thought and unique perspective is preserved as indestructible quantum information, where does the universe store all this infinite data? The answer pushes us beyond our observable universe into the most mind-bending territory in modern physics. If every quantum choice creates a new reality, we must dare to look beyond the dark. As we prepare for the next step on our cosmic journey, we must ask if our universe is just one tiny bubble floating in an endless sea of other realities. Are there countless other versions of you living out every possible iteration of your life in the staggering beauty of the multiverse? Have you ever stood entirely alone beneath the vast, quiet canopy of the night sky, watching the ancient light of a million distant stars, and felt the sudden, heavy weight of a single, haunting question? We all carry a secret, invisible garden of alternate lives inside our minds. We wonder what would have happened if we had taken that other job, if we had spoken those unspoken words to a fading love, or if we had simply turned left instead of right on a quiet Tuesday morning 10 years ago. In our everyday classical human experience, we believe that the path we are walking is the only path that is real. We believe that every time we make a choice, the other option simply vanishes into the cold, empty void of non-existence. But what if the universe does not work that way? What if the cosmos is so infinitely vast, so overflowing with boundless mathematical potential, that absolutely nothing is ever truly lost? What if every single choice you have ever made and every choice you have ever avoided actually spawned a completely new physical reality? Before we step across the threshold into this breathtaking, infinite labyrinth of possibilities, I want to take a gentle, quiet moment to welcome you back. I am Theodore, the researcher, and it is a profound privilege to share these deep cosmic explorations with you. I noticed recently that 71% of the wonderful people who watch these videos and join us on this journey have not yet subscribed to the channel. If you find peace, comfort, and a deep sense of wonder in these late-night explorations of the universe, please consider subscribing. It helps our small community grow immensely and ensures we can continue to wander through these infinite mysteries together in the quiet dark. Now, let us return to the beautiful, terrifying mathematics of the multiverse. To truly understand how the strict, unforgiving laws of physics might support a reality where every possible outcome actually happens, we must return to the foundational mystery that has guided our entire gentle journey: the collapse of the quantum wave function. For decades, the greatest minds in science, the brilliant architects of modern physics, accepted a framework known as the Copenhagen interpretation. This framework insisted that a quantum particle exists in a state of infinite, shimmering probability, occupying many places and states all at once, until a conscious observer looks at it. The very act of looking, the measurement itself, forces the universe to abruptly roll the cosmic dice, throwing away all the other possibilities and settling on just one single, solid reality. But this sudden, violent collapse always bothered a young, brilliantly imaginative physicist named Hugh Everett III. In 1957, while working on his graduate thesis at Princeton University, Everett proposed an idea that was so radically profound, so deeply unsettling to the established, rigid scientific community, that it was initially met with overwhelming silence, polite dismissal, and academic rejection. Everett looked deeply at the beautiful, continuous mathematical equations that govern the quantum world and realized something staggering. There was absolutely nothing in the mathematics that proved the wave function ever actually collapses. Everett dared to ask a terrifying, beautiful question. What if the universe never throws any possibilities away? What if, instead of collapsing, the universe simply divides? This is the birth of the many worlds interpretation of quantum mechanics. Imagine that same solitary photon of light approaching the two narrow slits in our classic, quiet laboratory experiment. According to Everett, when the photon reaches the barrier, it does not magically choose to go through the left slit or the right slit. Instead, the entire universe physically splits into two distinct parallel realities. In one universe, the photon travels through the left slit. In the exact same moment, in a completely separate, equally real universe, the photon travels through the right slit. The observer in the laboratory also splits. One version of the scientist writes down that the particle went left, and the other version of the scientist, in a separate branch of reality, writes down that the particle went right. Both observers are absolutely convinced that their outcome is the only true, solid reality. They are both entirely unaware of the other's existence, separated by an invisible, impenetrable dimensional wall. Let us take a slow, deliberate breath and truly try to absorb the sheer, terrifying scale of what Everett's mathematics are suggesting. The universe is not just splitting when physicists perform highly controlled experiments in cold, isolated laboratories. The universe is splitting every single time any quantum particle anywhere in the entire cosmos interacts with another particle and presents multiple possible outcomes. It is happening billions upon billions of times, every single microscopic fraction of a second. It is happening inside the burning, violent hearts of ancient stars. It is happening in the cold, swirling dust clouds of distant nebulas. And it is happening right now, millions of times over, inside the very atoms of your own breathing body. Reality is not a single solitary road winding through the dark. It is an infinitely branching tree, growing outward into a higher dimensional space with such staggering, unimaginable complexity that it completely defies the limits of the human imagination. If we gently merge this breathtaking, infinite branching of reality with the profound concept of the quantum God, the universal observer we have been exploring, we arrive at a vision of the cosmos that is so majestic it borders on the divine. In our earlier reflections, we imagined the universal awareness looking down upon a single, solid, four-dimensional block of space-time, experiencing the entire history of one universe in a single, timeless gaze. But the many worlds interpretation demands that we exponentially expand our understanding of this foundational consciousness. If there are truly an infinite number of parallel universes, an endless ocean of divergent timelines constantly splitting and multiplying into the dark, then the universal observer is not just witnessing one single narrative. The quantum God is simultaneously experiencing, processing, and holding together absolutely every single possible version of reality that the laws of physics will allow. Imagine a consciousness so vast, so unfathomably ancient and complex, that it can simultaneously live through the eyes of every single version of you that has ever existed across the infinite branches of the multiverse. In one branch, you are sitting quietly, exactly where you are right now, listening to these words and feeling a gentle sense of wonder. In another branch, separated only by a microscopic quantum fluctuation that happened a decade ago, you are walking along a cold, wind-swept beach under a completely different sky. In yet another branch, you are gazing out at the stars from the deck of a spacecraft, or you are living a life of quiet, peaceful solitude in a deep, green forest, listening to the rain fall softly against a wooden roof. To our limited, fragile biological minds, these alternate lives are completely inaccessible ghosts, phantoms of what might have been. But to the universal observer, to the deep, underlying quantum mind of the cosmos, they are all equally real, equally vibrant, and equally precious. The universe does not play favorites with reality. Every single mathematical possibility is allowed to bloom, to breathe, and to fully experience itself in the grand, infinite garden of the multiverse. This profound realization completely transforms our human relationship with regret, sorrow, and the terrifying fear of making the wrong choice. We spend so much of our fleeting, beautiful lives agonizing over the paths we did not take, mourning the opportunities we believe are lost forever in the unforgiving river of time. But the many worlds interpretation softly whispers that nothing is ever truly lost. Every choice you did not make here was made by another version of you, just as real, just as conscious, and just as deserving of love in a parallel branch of the great cosmic tree. The universe, in its infinite, boundless compassion, refuses to let any potential go to waste. Every single note in the grand cosmic symphony gets played. Every single story is written and read by the universal mind. When we look up at the vast, silent night sky, we are not just looking at a single, lonely universe drifting in the void. We are looking at the faint, shimmering edge of an infinite, dimensional tapestry where every possible variation of existence is simultaneously unfolding in perfect, silent harmony. The silence of the cosmos is not the sound of an empty, terrifying void. It is the overwhelming, unified hum of an infinite number of realities vibrating together in a state of absolute, perfect wholeness. We are not just temporary wanderers in a single, isolated world. We are multidimensional expressions of an ancient, infinite awareness that is endlessly exploring its own boundless potential. Every time you feel a sudden, inexplicable sense of déjà vu, every time you experience a vivid dream that feels more real than waking life, perhaps you are experiencing a gentle, microscopic bleeding of quantum information across the invisible boundaries of the multiverse. Perhaps you are feeling the subtle, quiet resonance of your other selves, living out their own beautiful, complex journeys in the vast, unseen branches of the cosmic tree. As we slowly prepare to conclude this profound meditative journey into the heart of the quantum universe, we must gently gather all the pieces of this staggering puzzle. We have explored the terrifying observer effect, the deep interconnectedness of quantum entanglement, the illusion of time, the holographic nature of reality, and the breathtaking, infinite branching of the multiverse. We have traced the outline of a quantum God, a foundational universal awareness that reads the cosmic code and holds the infinite realities in place. But the final, most important question still remains softly suspended in the dark. How does this overwhelming, mind-bending cosmic knowledge actually change the way we live, our quiet, daily human lives? As we step into the final chapter of our gentle exploration, we must bring the infinite vastness of the cosmos back down to the beating, fragile human heart. If we are truly the universe experiencing itself, how do we find meaning, purpose, and lasting peace in a reality built from shifting probabilities and infinite illusions? Let us take one last quiet step together into the profound light of understanding. We have traveled incredibly far together, crossing the staggering, almost incomprehensible boundaries of space, time, and human imagination. We have stared deeply into the invisible, shimmering heart of the quantum realm, watched the violent, ancient birth of the cosmos, and stood on the precipice of an infinite, branching multiverse. But as we slowly and gently bring our minds back from the furthest edges of the cosmos, returning to the quiet, fragile reality of our daily human lives, a profound and deeply personal question remains floating gently in the dark. How does all of this magnificent, terrifying knowledge actually change the way we live? When you wake up tomorrow morning, pour a simple cup of warm coffee, and step out into the bright, ordinary light of the day, how do you carry the staggering weight of a quantum universe inside your chest? It is so incredibly easy to look up at the infinite, silent expanse of the night sky and feel entirely, hopelessly insignificant. Our Earth feels so impossibly small, a tiny speck of dust suspended in a vast sunbeam, as the legendary astronomer Carl Sagan so beautifully and poetically described it. Before we weave these final beautiful threads of our cosmic journey together, I want to gently remind you that I am Theodore, the researcher. It is a profound honor to walk through these ancient mysteries by your side. I noticed recently that roughly 71% of the wonderful, curious souls who watch these videos have not yet subscribed to the channel. If you find comfort, peace, and a quiet sense of wonder in these late-night explorations, please consider subscribing. It helps our small community of cosmic explorers grow immensely, ensuring that we can continue to gently wander through the infinite dark together. Now, let us discover how the deepest mysteries of the universe provide the ultimate comfort for the human heart. When Voyager 1, our small, brave, mechanical ambassador to the stars, turned its cameras back toward Earth from a distance of nearly 4 billion miles away, it captured an image that forever changed human perspective. In that photograph, our entire world is nothing more than a pale blue dot, barely a single pixel of light, caught in the vast, unforgiving dark. Looking at that image, it is natural to feel a sudden, terrifying sense of meaninglessness. If the universe is 13,800,000,000 years old, and if there are trillions of galaxies stretching out into a cold, expanding void, what could possibly be the significance of one tiny, fleeting human life? What does it matter if we love, if we grieve, or if we simply sit in the quiet grass and listen to the wind? But the quantum universe, the beautiful, deeply counterintuitive reality we have been exploring, completely shatters that cold, classical sense of insignificance. It takes the vast, terrifying scale of the cosmos and gently folds it right back into the palm of your hand. If the theories of the universal observer are true, if the cosmos fundamentally requires a conscious mind to collapse its infinite waves of probability into a single, beautiful reality, then you are not an insignificant accident. You are an absolute physical necessity. The universe is not a massive, indifferent machine that simply happens to contain you. The universe is a grand participatory performance, and you are playing a vital, irreplaceable instrument in the symphony. Every single time you look at a blooming flower, every time you feel the rough, ancient bark of a towering tree, and every time you gaze up into the silent, star-filled sky, your consciousness is actively participating in the creation of reality. You are the universe looking at itself, feeling its own warmth, and trying to understand its own magnificent existence. The brilliant astrophysicist Neil deGrasse Tyson often speaks of this profound cosmic connection, reminding us that we do not simply live in this universe, but the universe lives exactly within us. The heavy iron coursing through your blood, the rigid calcium forming your bones, and the complex nitrogen in your brain were all forged in the violent, burning hearts of ancient stars that lived and died billions of years before the Earth was even born. When we begin to internalize this profound scientific truth, the heavy, anxious burden of our daily lives begins to gently lift. We spend so much of our time worrying about the relentless march of the clock, agonizing over past mistakes, and fearing an uncertain future. But if we are truly living in a magnificent block universe, where all of time exists simultaneously, then our past is never truly gone, and our future is already resting safely in the eternal fabric of space-time. The deep, painful losses we experience, the loved ones who have gently slipped out of our biological reach, are not erased from the cosmos. Their laughter, their warmth, and their quiet moments of love are permanently, indestructibly encoded in the quantum information of the universe. They are still there, perfectly preserved in the ancient, unyielding diamond of time. And if the many worlds interpretation holds the true shape of reality, then we are freed from the paralyzing fear of missed opportunities. Every choice we did not make is being lived fully and beautifully by another version of ourselves in the infinite, branching canopy of the multiverse. We can finally forgive ourselves for not being everywhere and doing everything, because across the vast, boundless landscape of parallel realities, we already are. The concept of a quantum God is not a rigid, terrifying dogma meant to restrict our lives or judge our human frailties. It is a scientific, contemplative framework that offers a profound, overwhelming sense of peace. It suggests that the foundational awareness of the universe is not watching us from a distant, separate throne, keeping a cold ledger of our actions. Instead, it is experiencing the world through us. We are the sensory organs of the infinite. When you feel a sudden, quiet wave of joy, the universe is feeling joy. When you sit in the heavy, silent depths of sorrow, the universe is learning what it means to grieve. We are completely, inextricably bound to the very fabric of existence. The illusion of separation, the painful, lonely feeling that you are an isolated creature fighting against a cold, uncaring world, is just that, a biological illusion. You are a localized wave of awareness in an infinite, boundless ocean of consciousness. When your biological journey finally concludes, that wave does not disappear. It simply relaxes its shape and merges back into the gentle, ancient sea from which it arose. This realization should fundamentally change the way we interact with the world and with each other. If every single person you meet is another localized expression of the exact same universal mind, another avatar exploring the exact same cosmic simulation, then every act of kindness is an act of kindness toward yourself. Every moment of empathy is the universe gently holding its own hand. The staggering complexity of quantum mechanics, with its entangled particles and its delayed choice experiments, ultimately points us toward a deeply human philosophy of connection. Distance is an illusion. Separation is a trick of the mind. We are all deeply, invisibly entangled with one another, communicating across the void, silently agreeing upon the shape of reality so that we can share this beautiful experience together. As we stand at the end of this current journey, looking out at the vast, starry expanse of human knowledge, we must embrace the most beautiful, comforting truth of all. We do not have all the answers. The theories we have explored, the mathematics of the multiverse, the holographic principle, and the deeply unsettling observer effect are our best, most courageous attempts to translate the infinite mystery of the cosmos into a language our finite minds can grasp. But the universe will always remain infinitely more complex, more beautiful, and more deeply strange than we can ever fully articulate. And that is not a tragedy. It is a magnificent, awe-inspiring gift. It means that the journey of discovery will never truly end. There will always be another beautiful mystery waiting in the dark, another quiet question calling us out into the unknown. The pursuit of scientific truth is not about building a rigid, final wall of facts that locks the universe into a boring, predictable box. It is about constantly pushing the boundaries of our own ignorance, expanding the sphere of our awareness so that we can touch even more of the magnificent unknown. It is a form of deep, active meditation. Every time we turn a telescope toward a distant, ancient galaxy, every time we smash subatomic particles together in a cold, underground accelerator, and every time we sit alone in the dark, pondering the strange, jittery nature of our own consciousness, we are participating in a sacred cosmic ritual. We are the universe, trying to wake itself up. Let us linger for just a moment longer in this quiet, shared space of contemplation. Think about the sheer unlikelihood of your existence. Out of the chaotic, swirling inferno of the early universe, out of the violent, crushing collisions of dead matter, the cosmos somehow managed to organize itself into a form capable of love, of mathematics, of poetry, and of deep existential longing. This is the true miracle of the quantum observer. We are the mechanism by which the universe transforms cold, abstract potential into warm, breathing meaning. Without your specific, unique perspective, a tiny, irreplaceable piece of the universe's own history, would go unwritten. You hold a piece of the cosmic puzzle that no one else, across the entire vast expanse of time and space, can ever hold. Your quiet moments of observation, your silent tears, and your sudden bursts of laughter are permanently recorded in the grand, indestructible library of space-time. You matter to the cosmos, not in a trivial human sense, but in a profound, fundamental, physical way. So, the next time you find yourself awake in the deep, quiet hours of the night, when the house is entirely still and the world outside feels impossibly vast, do not let the silence frighten you. Do not let the staggering scale of the cosmos make you feel small. Instead, step outside. Let your eyes adjust to the ancient dark. Look up at the pale, shimmering band of the Milky Way, holding hundreds of billions of stars in its slow, majestic embrace. Feel the cold, crisp air moving gently into your lungs, built of atoms that were forged in the furious fires of deep time. You are not a stranger here. You are not an accident. You are the universe itself, finally opening its eyes, taking a long, deep breath, and feeling a profound, beautiful sense of wonder. We will leave this specific mystery here, floating gently in the quiet space between what we know and what we have yet to discover. But our journey together is far from over. The cosmos is vast, and there are countless other ancient, beautiful secrets waiting for us to explore them. Thank you for walking through this infinite, starry landscape with me. Thank you for bringing your curiosity, your open mind, and your quiet sense of wonder to the edge of the unknown. Keep your eyes on the stars. Keep asking the terrifying, beautiful questions. And remember that you are an essential, beautiful piece of the grand cosmic puzzle. As the night gently deepens and the world slows down, carry this profound peace with you into your dreams. I will be here, waiting in the quiet dark, ready to take the next step with you whenever you are ready.